In this video, we'll learn one last format for determining slope, and that's if you're only given 2 points. So we're going to look at what would happen if you're only given 2 points, so something like what we see here. And how can we find the slope of the line that would go from point to point? So to help us, let's start by creating a table for ourselves. So the first point that we have is 2, 4. Remember, points are listed as x, y. And then the second point is 1, 7. So if we see it that way, that could help us find the slope, because we know that from a table, we start with that change in y. So here we're increasing by 3, and then move to the change in x, which here we're actually decreasing by 1. So that would help us see that the slope of change in y over change in x would be 3 over negative 1, which is the same as negative 3. So the question is, how can we learn to do this without creating a table for ourselves? So if we think about what change means, we're really talking about the difference between those y values. So if we notice, taking a look at the y values here of 7 and 4, we can subtract those to get a difference or change of 3. So again, 7 minus 4. Then if we do that same thing for x, we can see that 1 minus 2 would give us that negative 1 change in x. So change and difference go hand in hand. Let's look at creating a formula to help us with this. So what we were just talking about is the fact that your change in y, or the change in y, can come from really subtracting your y values, and then your change in x can come from subtracting your x values. So the problem with this type of formula is it looks like you could just subtract those and get 0. So we need a way to tell which y value we're talking about. Because if we think about our points, they both have an x and they both have a y. So this is going to look scary at first, but once we get through it, I promise it won't be that bad. So in order to kind of distinguish which x value, which y value we're talking about, we use something called subscripts. So you almost look like reverse exponents, because instead of at the top, they're at the bottom. But essentially all these are little labels. So that x1 doesn't change the number at all. It's just a label for the first x and the first y compared to the second x and the second y. So starting from your second value, we're going to take the second y and subtract the first y, and then subtract the second x from the first x. And we'll kind of look at how we work with that. So again, I promise it's not as scary as it looks. So what we're going to see is kind of playing around with these and seeing if it matters what order you decide to subtract in. So to start, I'm going to call this my x1 and y1, again, really just for first y, first x, and then my second x and second y. So I'm going to start by doing the formula that I have up here, which is my second minus my first. So if we look, my y2 value is negative 5, and my first y value is 1. So negative 5 minus 1 compared to my second x value, so 8 minus 6. So if I do negative 5 minus 1, I get a negative 6, and 8 minus 6 would be 2. So here, my slope of my change in y over my change in x would simplify down to negative 3. So let's see what happens if we flip that, and starting with the first y values. So maybe like y1 minus y2 and x1 minus x2. And again, I'll write these in at first because I do think it helps when you're first getting started. So my first y value would be 1. So 1 minus negative 5. And then my first x value is 6 minus 8. So remember, when you're subtracting negatives like this, it's the same as adding. So this really becomes a positive 6, and then 6 minus 8 would be negative 2. Good news is 6 divided by negative 2 is still equal to negative 3. So as far as doesn't matter which one you start with, no. Difference is kind of where our negative was. Here it was in the numerator, here it's in the denominator. But it really doesn't matter because they're both equal to the same thing. So here's what does matter: consistency. The fact that my two starting numbers came from the same point is crucial. No matter what point you choose to use first, you have to use it first and both your y's and your x's. So what I mean by that is I couldn't pick this y value to use first, but this x value to use first. So whichever point you use first, keep that consistent for both your y's and x's. If I'm scaring you a little bit, I promise it does get easier the more and more you practice with this. So if we look at these 2 points, another strategy I kind of recommend is writing out these labels for yourself, and then it helps you follow kind of that formula a little bit better. So I'm going to do what the formula says, and I'm going to start with my second point here. So y2 minus y1 and x2 minus x1. So again, starting with that point that I chose, that would be 8 minus the other y value of -4. And then that same point for that starting x value, so 2 minus -6. Again, subtracting a negative is the same as adding a positive. So all of this would be equal to 12 over 8. Both of those can divide by 4, so that would give me 3 over 2 as my final slope. So really I would say the key for this is just to remember that change and subtraction or difference go hand in hand. So if you're looking for your points, find the difference, find the change of each your y's and your x's. So I'm actually going to show you some of the mistakes that I tend to see when people are first trying this. So this says to find the slope of the line passing through the 2 following points. We have -1 and 5 and 3, -2. So if we look at all of this, we have kind of x1, y1, x2, y2. So looking to start, this -2 minus 5, they did do y2 minus y1, so that's a great start. That is correctly -7. If we look at the x's though, this x comes from this point, but my first y value came from the other point. Remember, consistency is key. So here they decided to do x1 minus x2. But the thing is, these starting points have to come from the same thing. So kind of your 2 ways to do this would be -2 minus 5 and then use the 3. So 3 minus -1. Or to switch it, if you want to do -1 minus 3, then you got to switch those y's and do 5 minus -2. Consistency is key. Pick the same starting point for both your y's and your x's. One more mistake to find. So here we have the points 4, 9, and -2, -1. So if we look, again, I'll kind of label these to help know which ones we're talking about. So it looks like they did, x minus x, and then y2 minus y1. So here they flipped which one they should go in the numerator. So y's, even though it's the second value listed, needs to go first. So these need to be flipped, which means these would need to be flipped. There's kind of 2 mistakes in this one, maybe you've noticed. So really we're saying this should be -10 over -6. And the other small mistake here is actually this negative. If we think about 2 negatives, both of those would cancel out. So this would be the same as +10 over 6, which would really be a +5 over 3. So those 2 mistakes would be y's have to go on top, change in y over, change in x. And if you're ever in the instance where you get double negatives, remember your final answer would be to simplify that to a positive value.